everyone. My name is Colin Rush. I lead Oppenheimer's Sustainable Growth and Resource Optimization research practice here. We're thrilled to have the Amprius team here, CEO Kang Soon and CFO Sandra Wallach. We'll go through a presentation with the company and then do a little bit of Q&A afterwards. So with that, I'll pass it over to you, Kang, to give us an introduction to the company.
Morning, thank you. I'm glad to have this opportunity to introduce Amprius technology. Let's see if I can get my slide moving. Okay, Colin, thank you. Amprius is the pioneer developer and manufacturer high energy density of high power density silicon anode lithium-ion batteries. We start with the technology come from Stanford University back to 2008. Then we start the full operation in 2010.
Kang, we can see your slide on the timeline.
Yeah, but I hear myself talking. Somehow the previous talking, come back again. Yeah. So, okay, let me start from this page. Yeah. The Amprius is a pioneer developer and manufacturer high energy density and high power density silicon anode lithium-ion battery. Yes, can you hear me?
Yep, we can hear you just fine, Kang. Hi, everyone. Sorry for the trouble there. We are back. My name is Colin Rush. I lead the Sustainable Growth and Resource Optimization team here at Oppenheimer, and we are thrilled to have Kang Soon, CEO of Amprius, along with Sandra Wallach, the CFO of Amprius, and I think we have our technical difficulties worked through. So with that, I'll turn it over to Kang to give us a little bit of background on Amprius.
Colin, thank you. Glad to have this opportunity to introduce Amprius technology. Now, Amprius technology is a pioneer developer and a manufacturer of high energy density, high power density silicon anode lithium-ion batteries. Today, we have most complete silicon anode technology portfolio. The company started 2008 with the technology came from Stanford University. 2014, we designed the first high-capacity silicon anode. 2016, we developed the manufacturing process and the equipment. 2018 is a major milestone for Amprius. We secured the first customer, Airbus, for high-altitude pseudo-satellite battery business. 2022, we launched the IPO at the New York Stock Exchange. Since then, we developed various technology platform, SiMaxx, SiCore, and we secured a 1.8 gigawatt manufacturing capacity today. So Amprius developed the breakthrough technology. We also deliver breakthrough performance. Today, we have the highest energy density and power density battery in the commercial market. Our battery can perform up to 500 watt per kilo and 1300 watt per liter. This is very significant. As a reference, most of the battery today in the market is between 260 to about 300 watt per kilo. And your smartphone probably have 700 watt per liter volumetric energy density. We also have a high power density for electrical mobility applications. Our battery can charge you from 0 to 80% less than 6 minutes. And very important, we passed the military performance spec nail penetration test years ago. Our battery also can operate from minus 30 degrees to 60 degrees Celsius. Now, we have years manufacturing experience. We started first production back to 2018. These are some major performance. We have a 500 watt per kilo battery, 1300 watt per liter. Those number actually is very, very important and very impressive, because today we deliver twice higher energy density in commercial market. Then our revenue, you can see we grow our revenue year after year, quarter after quarter. You know, we just had a Q2 earning release. The company made a very impressive progress. Now we have a very large customer pipeline here. We have over 320 customers engaged with us, a technology collaboration, purchase agreement, and various collaborations. Company has over 80 patents in silicon anode technology space. And today we have international business. 86% of our customers are outside the United States. Very, very important is the manufacturing capacity we have and the manufacturing capability we have. So you look at Amprius, we know how to design, and we know how to make, and we know how to sell. So that's the three key elements for to make a progress. So we look at the 2025, we have a breakthrough SiCore technology introduced to the market. We introduced this technology back to January 2024 and make a significant progress in technology advancement, also in marketing and sales. We shipped a high-end performance battery, 6.3 ampere hour cylindrical cell to Fortune 500 company. In today's commercial market, most 21700 cylindrical cell normally is 5.8 ampere hour. Most then the larger fraction is even 5.5 ampere hour. So 6.3 is very, very significant. Then not long ago, we have launched the SiCore 450 watt per kilo high energy density cell, with a near-term mass production capability built up. Revenue, we have a 4.6x year-to-year revenue growth driven by new customer orders. We look at our major milestones. Then 2025, we secured a $15 million purchase order from a leading UAS manufacturer. And very importantly, we invite Tom Stepping joined us as president. I know Tom for 20 years. He is a superb business operator. Then we added additional manufacturing capacity in South Korea. This is very important for us as well. We have diversified the manufacturing region today. So Amprius, the key play is silicon anode. So why silicon? Why use silicon to replace graphite? You know, for 20 years ago, the battery industry facing capacity crisis because we cannot talk on the phone longer. You know, then it's very difficult to build EV batteries based on original technology. So the company, the industry is hungry for power density, energy density. So silicon has a 10 times energy density than carbon. So it's an obvious option for new lithium-ion battery anode. However, the silicon has a very high volume expansion coefficient. So it's very difficult to control the silicon anode swell. Even silicon is safe, is low cost, abundantly available, except the oxygen that on the Earth's crust, the silicon is available. Now, easy to process, 10 times energy density, but the swelling is the issue. Now, what Amprius accomplishment is control, mitigate, or eliminate the silicon swelling. So today, as I mentioned earlier, we have most complete silicon anode technology. Our SiMaxx anode has a 3,400 milliamp hour per gram. Literally is 10 times higher than graphite anode today. This is just not just the element, silicon element compared to the carbon. This is the anode, complete the anode compared to graphite anode. We have 10 times and higher energy density. Silicon is, Amprius is the only company has anode which is 10 times higher than silicon graphite anode. So this is some real world testing data here. First on the left, you can see, we have 500 watt per kilo compared to most popular graphite battery, commercial battery today, almost double the energy density. Then compared to the graphite in terms of volumetric energy density, we almost double the volumetric energy density as well. On the left-hand side, these are real case test. We put our battery in one of customer drones. Okay, we deliver 42 minutes flight time compared to their current 24 minutes flight time. In the video capable smartwatch, in the military comfortable wearables, in electrical vehicles, in every application, Amprius battery delivered twice the mission time. We have two technology platforms, SiMaxx and SiCore. SiMaxx is a silicon nanowire anode technology, is pure 100% silicon without any other active materials. Again, this is only 100% silicon anode in the industry. So you can see the Amprius has many onlys. We are the only 500 watt per kilo battery manufacturer. We are the only 3,400 milliamp hour per gram anode manufacturer. We also the only pure 100% silicon anode lithium-ion battery manufacturer. In addition to that, we also have a SiCore platform. SiCore actually has 100% silicon also, but SiCore has some inactive materials like polymer binders and other additives, but can be used without the graphite. We look at this map, this performance map. We have on the vertical axis is energy, on the horizontal axis is power. So what this shows? This shows Amprius battery occupy entire battery performance space. We can tailor our battery for various applications: high power, high energy, and high power, high energy. Also, high power and high energy. Anywhere customer need their battery to perform, we have a solution for. Now, this is a simple comparison. Our battery to graphite, of course, we beat the graphite performance in every category. This is our SiMaxx platform. SiMaxx, you can see, is very, very unique. Okay. It's the only silicon anode structure in the industry. This is silicon nanowire structure. This structure enables us to have fast charging, high energy density. Also give us very high power. So for the SiMaxx, we have some commercial product available. 450 watt per kilo. We have been selling this to customers for some time. Recently, we have third-party certification qualification for 500 watt per kilo battery as well. This is a generation ahead of the game in lithium-ion battery industry. Today, we have not seen any battery can perform beyond 350 in commercial space. This is a SiCore. This is a very important platform for Amprius. we consider this is the second generation Amprius silicon anode battery technology. Its performance is approaching the performance of SiMaxx today. So for SiCore, today we have 700 watt per kilo and 910 watt per liter battery. I mentioned that for your smartphone, today probably 700 watt per liter. Most of those are 680 watt per liter. We already have a 900 watt per liter battery. So I mentioned that the SiCore performance is approaching SiMaxx. 400 watt per kilo battery is SiCore battery is available. There is another very amazing battery performance here. Is a balanced energy and power density. This is the only one in the today's commercial industry. We can deliver 350 watt per kilo battery and 805 watt per liter. Most importantly, this can continuously discharge at 3C and 5C at pulse. This is a very important design and performance. So we have two types batteries. Now we have both of those battery platform, SiMaxx and SiCore, can leverage current industrial manufacturing protocol. For SiMaxx, the anode part, we use solar industry manufacturing equipment, currently from Centrotherm. We use this equipment to make the anode. Rest of the manufacturing process are the same as the industry is doing. We actually can make the anode and give to somebody else to make the entire battery. For SiCore, even better. Even the anode can use other people, the current traditional industrial manufacturing process to produce SiCore anode. So the manufacturing is not an issue for us. We don't have to reinvent the wheel to manufacture Amprius high energy density, high power density lithium-ion batteries. A couple years ago, we decided we use contract manufacturing model, just like Apple, made in California, manufacturing someplace else. We do the design, we do the marketing, we do the sales. For now, we leave the manufacturing to our manufacturing partners. This is a capital light market. We don't have to spend a lot of capital to build a factory. We don't have a manufacturing team on the ground. We don't need to have buy factory insurance. We don't have to worry about the inventory. We even don't need a working capital in many cases. This is a great manufacturing model for Amprius. We have been practicing this over a year and a half, and we have great results. Today, we have a manufacturing facility in Asia, as you see. Also, we are developing contract manufacturers domestically. So our focus in several areas, the primary focus is aviation. Okay, in aviation, there are 4 areas we are working with. The first one is drones. This is an enormous opportunity today and even bigger tomorrow. Now, we command firm leadership in drone battery performance. I would say we engage with all reputable drone manufacturers today. The second area is we familiar the most. We started developing, supplying this battery back to 2018. That's high altitude platform system. Our first customer was Airbus back to 2018. You consider this as a low-hanging drone as well. And the third area is eVTOL. The eVTOL is moving forward faster than I thought. So we have engagement with the manufacturer of eVTOL as well. The last one actually is a very large battery user, is a fixed-wing electrical aircrafts. Our second market focus, we call micro-mobility, is a light electrical vehicle space. That's including e-bikes, motorcycles, two-wheeler, scooters, all those kind of light electrical vehicle applications. We are in the leading position. We start selling battery to this market in 2024. Here are some of our customers we can disclose. Airbus, I mentioned a few times, is very important. The first customer, important customer, and still the very important customer to us. Our battery enabled Airbus helps business successful today. Then we have Teledyne FLIR. We supply the battery for their drones. We have AeroVironment. We have quite a few news release with the company, BAE Systems, US military. We also engage with electrical vehicle battery technology in development. We don't have a commercial product. In the near term, that's not our focus. But technology-wise, we have battery ready. Not long ago, we shipped the sample to United States Advanced Battery Consortia for probably the highest energy density and the power density battery in the industry. Amprius battery can be used for all applications. Now, we can, for aviation, for light electrical vehicle, for consumer electronics, some industrial power applications, marine powers. We can use for many applications, but today our focus are aviation, micro mobility, some AI related space like robotics. So we look at Amprius. These are four important points I want the audience to take away. The first, we have industrial leading technology and enable best-in-class performance. The second part is very important. Without our battery, our customer will not able to achieve their technology and economic targets. Then we have a gigawatt scale manufacturing capability. We have this capital light model. Basically, we don't have factory. We don't have manufacturing team. All we have is we have best product, work with our manufacturing partners, and then they deliver quality product for us. The third one is we have a huge customer pipeline, over 320 here. Some of those customers at the top of the funnel now start purchasing our product. Then last, we have a very healthy balance sheet. We have no debt. Our current balance sheet cover quite a few quarters our operating cost. So in summary, we can design the best performing lithium-ion battery in the industry. Then we can manufacture various batteries. We can do cylindrical, we can do pouch, we can do prismatic, and use world-leading contract manufacturing partners' capability and capacity to serve us. The third one, we have a huge customer engagement. All those are important. As we said, design, make, sell. Now, this concludes my presentation. I'll be glad to answer some questions. My colleague, our CFO, Sandra Wallach, is online as well. If you have a question about our financial, Sandra can answer.
Yang, thanks so much for all that background. And I think, one of the things that we have been most excited about is the performance and the evolution of the performance, particularly with the SiCore technology. I think a lot of our investors like to look at IP and IP protection, and the battery space can be very challenging to understand what's defensible and what's not defensible. As you look at the competitive landscape and Amprius's platform, you guys have done a nice job with patents, but then there's an awful lot of know-how in actually producing these batteries. How do you think about your IP position and how you're able to defend it as folks start to look at investing more in some of these high energy dense and lightweight batteries?
Yeah, Colin, the First, I mentioned that we have over 80 patent developed during those years. Yeah, we have a patent on the fundamental concept of side core and SMX. Yeah. As you said, in the battery industry, okay, you hardly see the patent fight these days, okay, because the patent becomes a very important, very complicated issue. Many companies own various patents. Sometimes they are overlap. So very few. Last few years, I only see 2 patents fight. Okay, they finally settled. So for Amprius, now first, we are very confident. We have a strong intellectual property portfolio. Most importantly, as you mentioned, extensive, okay, know-how. This is very important. Yeah. So we have a very unique material system. We have a very unique cell chemistry. Then we have very unique cell design, and we have very unique manufacturing process. For example, for formation protocol, Amprius has a very unique formation protocol, enable us to make a high energy density, high power density lithium-ion, silicon anode-based lithium-ion battery.
Excellent. And so, as you continue to engage in customers, and we know that Tom was brought on in part to, help the organization really engage and get deeper with its existing customers. Can you talk about the incremental geographies, and what that can enable for you guys from a revenue perspective? Moving into South Korea, I'm sure met the requirements of some customers, but looking at potentially US or European manufacturing, I'm sure will open up even more customers. So can you talk about the importance of that capacity and how quickly that might translate into incremental orders and incremental revenue?
Yeah. Customer looking for 2 parameters, performance and economics. You can say performance and cost. Right? So when we select our manufacturing partner, those 2 things, in addition to those 2, of course, there's a quality there. The quality manufacture and the low cost manufacture. Those 2 things are very important. We can manufacture the place that the customer wants, but we may not be able to deliver the cost the customer wants. The customer still don't buy our stuff. So we did this very strategically and very carefully select those partners. So our manufacturing partnership today deliver not only the high quality, also deliver the economics our customer and Amprius can enjoy. Yeah. So we're looking forward. Today we already have a customer in United States, in Europe, in Asia. Yeah. So we believe this market already very, very large for us. Yeah. Otherwise, we wouldn't have 320 customer engagements here. So looking forward, I think strengthen our manufacturing base domestically and overseas are very, very important. As I mentioned, still the same thing we mentioned. First, we need to design superb product, which we have now, but we need to make sure we command performance leadership all the time. The second part is the manufacturing have to make it. Today we have Asian manufacturing partnership. We explore European, particularly Europe. We had a conversation with our German partners. Then we have domestic. Many people surprised how you can find a domestic contract manufacturer. Amprius is always creative enough to make things happen. So that could come to play soon as well.
Excellent. And, I think for many of the audience, there's been a lot of news reporting around solid state, right? And what solid state means in the battery world. We've made a pretty concerted effort around silicon anodes in our research practice based on the performance characteristics that we've seen, from the silicon anode focused companies. But can you just level set our audience around, what solid state means and how Amprius is positioned, to compete with some of the promises that are being made by other platforms, which, in some cases aren't even approaching, the commercial products that you guys have available today?
Right. Colin, as you know, you are expert in this field as well. The original solid state concept come from a lithium metal anode technology. Right? When we look at the silicon, when we talk about high energy density anode materials, the only two. One is silicon. Another one is lithium itself. Right? Both have a very similar energy density, around 400 milliamp hour per gram. The problem with lithium is a very active chemical element. Right? Lithium cannot expose to air, cannot expose to the water. As a matter of fact, we use lithium in our fireworks. So to use lithium metal as an anode, we cannot use a liquid electrolyte. So we have to use solid state. That's where solid state come from. This is back to decades ago. First lithium metal battery built in 1987 by Dr. Klaus Brandt, okay, in Germany. At the time, he working in Canada. So, but the people don't want to touch that again because their battery explode. Okay, the company bankrupt. So during those years, people try to find out, if I can have solid electrolyte, can I make a lithium metal as an anode? But very, very difficult. So far, there is no single company can make, even in laboratory, cannot successfully demonstrate lithium metal based solid state battery. Yeah. Still a huge battle. Yeah. So people started doing semi-solid state. Right? Have some solid state, basically is not a pure solid state. Is a semi-solid state. And let's talk about Amprius in this field. We have a concept, of course, we have not broadcast because we have not, we broadcast anything if we believe is commercially achievable. Otherwise, we don't make claims. You can see Amprius made no claim, the laboratory stuff. Anything we made claim, we already have customer validation. So we believe silicon can be solid state battery as well. And
excellent. And yeah, and if you can talk about the performance headroom and in terms of what you can achieve with silicon, if the material is similar to lithium in terms of potential performance, what's the actual performance and the practical performance in a product on a relative basis?
Yeah, if we have a solid state lithium anode battery, at this moment, we don't expect the energy density boost a lot. We don't expect the solid state, the silicon anode battery give us 600 watt per kilo. That's not realistic. But we can have same performance, but provide why we use solid state, because we want to have safety, right? You have once we don't have all the problem caused by liquid electrolyte.
Right.
Yeah, if a battery.
So you guys can have.
Yeah, we believe, okay, Amprius, we can have solid state based on silicon anode.
Okay, so just to recap, you can have similar performance and you're in commercial production now as anything that may be coming out of the solid state world in the coming years.
Correct. Yeah, although we don't have a commercial product today. I have to mention that. Yeah.
Perfect. So Sandra, just quickly on the balance sheet, because we just have a couple minutes here. The company has run very lean. Can you just talk about the balance sheet's efficiency, and your cash flow dynamics as you work towards hitting profitability through a fairly substantial ramp on revenue here over the next several quarters?
Yeah, great question. So we ended the second quarter with 54.2 million in cash. We've got no debt. We've got about $46.5 million left on an ATM facility, and our operating cash burn rate runs somewhere between $7.5 to $9 million a quarter. So as you mentioned, we run very lean. We were sub 100 employees full-time at the end of June. So because Kang has been able to put together this contract manufacturing strategy, we are not saddled with hiring several hundred people, buying inventory, managing working capital. We have and own the design and the specification, and we buy the finished product from our contract manufacturing partners, and serve our customers. So SciCore, which is the product that's been fueling our growth, has been cash flow positive since day one. So we believe that we're going to continue to see favorable cash flow from operations trend quarter over quarter, and that we've got enough cash on the balance sheet along with the ATM to make sure that we can get to cash flow positive.
Excellent. Well, listen, thank you both for being here, and thanks for everyone that's listened in. We are running into time here, so we are happy at Oppenheimer to help you get deeper into the story here at Amprius, and also put you in touch with the company as it makes sense. Please feel free to reach out. Look forward to talking with everyone soon, and have a wonderful afternoon. Thanks so much.